I will try to go quickly, so just in case. We were looking at air pollution in Ulaanbaatar, Mongolia, where I lived in 1993 to 1995. That's one of the reasons why we were looking at this problem. It's a country which is twice the size of Texas, yet it only has 3 million people. And that's very sparsely populated. The capital city has half the population of the country. And you can see here, it's nice and green during the summertime anyway. And when I lived there, it was a typical Soviet city. Mongolia was part of the Soviet bloc, so it was very similar to Poland or Hungary or Czechoslovakia and so on. And they had nice planned cities. And we would even see deer in the city. So within the city grounds, you could see deer back in the early 1990s. But things have changed since then. So since the Soviet Union has fallen, more people have moved into the city. So this is a city that was designed to hold about 500,000 people, and it now has 3 times that number of people. And Mongolia, for those of you who don't know, is in Central Asia, where it's really cold and dry. It's quite common for temperatures to reach to minus 30 degrees Fahrenheit and can get down to minus 40 degrees, which is the same on both the Celsius and Fahrenheit scale. So it is a very cold country. The picture there of that tent is a traditional Mongolian dwelling, and many people still live in that kind of living arrangement. Unfortunately, both the people who live in these kind of dwellings and the city itself is powered and heated by coal. And because winter is so cold, they don't really have a choice. There's not really any way around this. It's just a very cold country and you have to have heat. And a large part of the city is actually centrally heated. So unlike in, say, the United States, where you might have a water heater in your house, in Mongolia, much of the water is heated in the central power plant and then piped to all the various apartments and so forth. So if that went away, then people would freeze. I mean, it's really that kind of situation. And so with the city being very crowded and with the winter being very cold, you end up with situations like this. So smog is a huge problem in Mongolia. And you can see here in this picture slide here that it can be very difficult to even see the different buildings inside the city. The city itself is surrounded by mountains, so the air is not blown away during the day. And unfortunately, both the people who live in those gers, those tents, use coal to cook and to heat their dwellings. And also all of these buildings are heated by a coal plant. So that's why you see such huge amounts of smog here. Now, one of the issues that we've noticed in the research, and my paper will has the literature review, a much extensive literature review, but mostly people have been concerned about the average levels of pollution. And that's kind of misleading because in summertime, when they don't use the coal plants, it's not really as much of an issue. And in winter is when everyone's burning coal like crazy. So that's when you have these big problems. And it's really the heavy pollution days which are driving the health issues. So that was our research question, but we also had a different reason for studying this. And that is our particular school is a teaching school and we do a lot of project-based learning, and I'm in the computer information sciences. So we do things like we create sensors, we measure humidity and temperature and anything. We do a lot of Arduino sensor work. So we try to get our students hands-on, and we're trying to kind of inspire our students to know why they should study computers. So we don't just teach them how to program, we try to teach them to program for a reason, and that it could actually affect their lives and could affect their society. And one of the nice things about this particular case, Mongolia is a very interesting country for many people, but pollution, air pollution affects everybody, regardless of class, because the air pollution in the city, you can't escape it. Everyone has to breathe. So it doesn't really matter where in the city you live. The air pollution is really quite devastating. And which is one of the unique things about it too, is that the air pollution in Mongolia is from only 1.6 million people. We've all seen, much larger cities in India and China have these problems, but this is a very small city compared to the giant cities like Buenos Aires and Beijing and so forth. The other nice thing about this data, for those of you who would like to use it, it's from airnow.gov, where you can get the data online. It's measured daily. It's measured actually hourly, and it's very easy to get, and the data is very clean. So you're not going to have like a lot of cleaning to do of the data. It's just, you can give it to an undergraduate student and they can easily look at it. And in this particular case, for this particular city, the data is very seasonal, and it's driven by the maximums as opposed to a normal distribution. So that's a very nice thing for undergrads to see data which, we're not really concerned about 3 standard deviations, we're concerned about the maximum. So that's one of the reasons we were studying this. So just to give you a real quick background, you can see here that the population of Ulaanbaatar has exploded. So way back when I lived there, there was only about 500,000 people. But now in 2022, actually, it's estimated that 1.6 million people live there. And if you look at the number of automobiles, that's even exploded worse. So the city itself, when it was a communist capital, was made with large roads for having parades and trolley buses and public transport. It wasn't really made to have private automobiles. But now, sort of a sign of wealth for a Mongolian family is to have their own automobile, but yet there's not that many roads in the capital city. So you end up with these huge traffic jams. And as you can see, the number of automobiles has gone up tremendously over the past 30 years. This huge gain in population has caused the pollution. So most of what you see, all these reasons that have been identified in the literature for the rise in pollution is mostly due to the rise in population. So people have to eat, they need heat, they drive their cars. A lot of construction is going on, and that's just, they're building buildings as fast as they can. Even within the city, you have those gers, people living in gers. They call them a ger district, where poor people live. So they're just building things as fast as possible, and that causes a lot of dust and particulate matter as well. So just really quickly, we're flying through this, but sorry, we're just going as quick as we can. The key measure here that we were studying was this particulate matter 2.5. That's the number of micrograms per cubic meter. And it's supposed to be very low. So this is from the airnow.gov, which is associated with the EPA and so forth, where they want 12 micrograms per cubic meter or less in order to make it say that it's good. But you'll see when we get to when I show you the data that usually Mongolia is well down in this very unhealthy area. And we'll just skip this for now. But basically, hazardous is 301 micrograms or higher. So here you see the data. The green line represents what would be healthy, at least according to the EPA. And the red line is what would be considered hazardous according to the EPA. And you can see here that the data is clearly seasonable. It's very nice, very clean. But unfortunately for Mongolians, it's often in the hazardous region. In fact, the State Department doesn't even have a measure for anything over hazardous. They just consider it hazardous. They don't say super hazardous or anything like that. They just say don't go outside, basically. That's what they say. But of course, Mongolians have to go outside. They have jobs, they have to live. And so they're exposed to this kind of pollution every day. You can see that the pollution has kind of gone down towards the end here, but note that this is only up to the pandemic, actually. So we're not sure what is happening right now. We have the data, and it is a similar peak to this one here, this last one. But we'll see what happens now that COVID is kind of dying down. So for the health effects, it does affect everybody. People have already shown that the number of deaths in wintertime is quite much higher than in the summertime. There's quite a few of premature deaths. Children suffer from pneumonia. They are out of school. People have to miss work during the winter months as opposed to the summer months. And notably, one of the unfortunate effects is that there's quite a few miscarriages during the winter months compared to the summer months. And it's quite clear. So if you compare the number of women who have miscarriages in winter, it's quite a bit different. I mean, obviously that's not causal, but it does point to a very strong correlation of a problem there. So what we did was we were looking at it using the generalized extreme value distribution, or also the generalized Pareto distribution. So this is a way where you can try to model only the maximums of the distribution. So the difference being that if you take the daily pollution levels, and they're measured hourly, and you look at only the highest level for each day, and then you model that, that's the generalized extreme value distribution. And you can do this, it's very interesting. You can do it in Excel. Like if you flip a coin, or if you generate a random number between 1 and 100, and you do that 1,000 times, and you take the maximum level from that 1 to 100 for each series, you can model the generalized extreme value distribution. And it's really quite amazing how that works. The generalized Pareto distribution is similar, except instead of taking only the maximum value, you take, say, like the 5 highest values. So it's per day, because you're giving up some information. If, for example, there was a spike for 1 hour, and then everything was good for the rest of the day. Well, using the generalized Pareto distribution, you take the 5 highest levels of pollution and model that instead. And what it's used for, it's used a lot in engineering. So when they build a bridge, they use it to predict what the 200-year floods would be, for example. So it's fairly useful and used a lot in engineering. They use it to predict how big diamonds might be in a diamond mine. They use it to predict sea levels. What's the maximum sea level that will occur, for example, if there's a hurricane, so on, things like that. And in my paper, we'll explain it more, but because this data is seasonal and it's hourly, it's not independent from hour to hour, because the prior hour can affect the next hour. So you have to decluster the data. But essentially what's happening is that in the morning, before everyone gets up, the pollution is at its lowest level for the day. And then it increases as people go to work. And then as people start cooking lunch and dinner, the pollution gets higher. And then at nighttime, after 6 o'clock or so, between 6 and midnight, it gets to its highest levels as people have to heat their homes before they go to bed. And just to show the results of our model so far, you can see here we have the quantile plots. Our model is matching the data for the most part, except at these very high levels. If you look at the bottom left-hand graph here, you can see that we are fitting the general Pareto distribution, the expected values, fairly well. And again, what we're really concerned with are these maximum values, these long tails, because, for example, like in Hurricane Katrina, the hurricane was a lot stronger than they had predicted. So we're really concerned with the maximum values, not the other values. And then this is sort of the key piece of information that came out. If you notice the return levels here, this bottom right-hand graph, you'll notice that it kind of curves downward, and that's a good thing, actually. It's good because it means that we're probably not going to be rising in pollution. Of course, we can't really know that because the last couple of years have been kind of lower level of economy due to COVID. But anyway, that's the results we have so far, which we're going to move forward with. The bad thing about the return levels is that pollution, even though it doesn't seem to be rising, it's still going to be very hazardous for people. So what we plan. Yep.
Excuse me, you're out of time now. The next session has to start.
Okay,
yeah,
great.
That's what I thought.
Okay, sorry for the late start, and thank you for listening.
No problem. Thank you all very much. Sorry we don't have more time to visit with questions.